What do we know about teleportation? Heroes of science fiction films and computer games easily dissolve in the air, materializing in different parts of the universe. But in real life, this is not possible. Or is it? In fact, scientists have been actively working in this direction for more than 20 years, achieving amazing results. So, how close are we to creating a teleporter? Let's figure this out. By teleportation, we mean the instantaneous movement of objects at any distance, ideally faster than the speed of light. The word itself was invented in 1931 by the American publicist Charles Fort, who combined the Greek word tele, that is far away, and the root of the Latin verb portar, meaning to carry. In his book Volcanoes of the Sky, he used this term for the inexplicable movements of objects in space. Fort's book had no scientific basis. It was a collection of stories, legends, and myths about teleportation. Such transportation through space have indeed been talked about at all times. Unthinkable stories about teleportation sometimes pop up in the press. The American destroyer Eldridge, for example. In 1943, it allegedly traveled 320 kilometers from Norfolk to Philadelphia in an instant. Scientists were shocked and began to find out all the circumstances of this unique event. However, it turned out that the ship simply quickly sailed the distance between the cities along the canal. But to some scientists, teleportation no longer seems like something out of a science fiction movie. They've learned all possible methods of instantaneous movement and even managed to master some of them. What kind of teleport does science suggest? Do you like the idea of suddenly finding yourself on the other side of the world through a gap in space-time? And the teleport for this is already in your house right now. You just don't see it. But don't think that getting through it will be as easy as getting into a neighbor's yard through a gap in the fence. According to one of the scientific hypotheses, our world is full of microscopic holes. After all atoms are in constant motion and voids appear between them. Such a hole, a dozen atoms wide maximum, would be needed to expand somehow to the size of a person for someone to teleport through it. You'll also need to hold the hole empty so that it's not quickly filled with particles. Probably exotic matter with a negative charge would be suitable for this. It just hasn't been found yet. Scientists have suggested that some stars are giant clumps of exotic matter. However, this theory has not yet been supported by research. Theoretically, you could slip into the smallest gap in space, becoming a quantum wave. In quantum mechanics, such waves are bound by any microparticle. But it's not known how to make a wave out of a person in practice and then materialize them again. Wormholes can also become teleports. Scientists suggest that our three-dimensional universe is bent in the fourth dimension in some places. In these bends, there are tunnels, wormholes. This is where 2 points in space may have large distance between them in the third dimension, but in the fourth, they're almost in the same location. This is easy to imagine by folding a sheet of paper so that its two distant points touch. Poke this piece with a pen, and you get a model of a wormhole. There is an opinion in the scientific world that wormholes hide in black holes, but you can't get inside the black hole. An accretion disk of gas rotates around each of these monsters with incredible speed. It will immediately stretch you like spaghetti, and if you slip through the disk, you'll die from the crushing gravity of the black hole. If you somehow, nevertheless, fall into a wormhole, it will surely destroy you instantly. Wormholes are only open for a second, then they close. So the passage will have to be held in place. This is where the exotic matter would fit again, but we don't have it. One day you might find yourself in an unknown place. Open the door to the bedroom and you'll find yourself on a distant planet, not expecting that at all. And all because of the quantum instability of the electrons in your body, which randomly move around the universe. However, you should not be afraid. The probability of spontaneous movement is practically zero. The time when one such event occurs exceeds the age of the universe. But the wave functions of the atoms of our body nevertheless reach other planets. If you study and take control of their movement, then theoretically you can teleport people. This method is shown in the Douglas Adams film The Hitchhiker's Guide to the Galaxy. Whether this can be reproduced in real life, scientists do not know yet. Another thing is quantum teleportation. Its principles have already been developed and are being implemented in practice. The method involves not moving the human body, but information about it. It resembles what we can do using a fax. Let's consider the principles of quantum mechanics, which formed the basis of teleportation. Let's start with the fact that each electron in a quantum system belongs to all atoms. Otherwise, a molecule could not be built. In this case, an electron exists in all places at the same time, although it's difficult to imagine. Such a state is called a superposition. It's only when you start observing this electron that it gets fixed in a certain position. We can say that in the morning, getting out of bed, you change the universe with your first look. The famous mental experiment on this subject was carried out in 1935 by one of the founders of quantum mechanics, Erwin Schrödinger. Let's imagine that a cat was locked in a steel safe. There is also an infernal machine that, under certain circumstances, will kill this animal, or it will not. According to quantum mechanics, as long as the cat is not observed, it is both alive and dead at the same time. If the box is opened, then the experimenter can see only one specific state: the cat is dead or the cat is alive. Almost instantly, the system ceases to be a mixture of states, and it picks one of them at the moment when the observation takes place. Scientists have not yet found a complete explanation for this phenomenon. However, it has already been experimentally confirmed. In addition, electrons in quantum mechanics are connected in pairs and then diverge and randomly move around the universe. This is called the entanglement of electrons. They keep in touch with their twin no matter how far apart they are. Each electron has a spin, the direction of rotation in relation to the magnetic field. As soon as the spin of one electron from a pair goes down, that is, turns away from the field, then the spin of the other immediately goes up, and vice versa. If something happens to one of the bound electrons, information about it is instantly transmitted to the second, and it happens faster than the speed of light. This is the Einstein-Podolsky-Rosen paradox. Nothing can outrun light, but an entangled pair of electrons transmits information faster. To better understand the principle of such a connection, let's take an electron on Earth, E, and another on Mars, M. Once they were a couple, but then they flew apart. As soon as we determine the spin of the electron E, then we can immediately determine the spin of M. It'll be the opposite. And if we change the spin of E, it will also change for M. Moreover, we would see the change of the electron on Mars instantly, faster than the speed of light. In 1983, the French physicist Alain Aspect decided to test the paradox by conducting a series of experiments with electrons. He confirmed that information between entangled pairs is transmitted faster than the speed of light, but it is random and useless in practice. However, 10 years later, scientists found a way to control this process by connecting a third electron to an entangled pair, and they were able to teleport individual electrons. Here's how it all happens. Take the electron E on Earth and M on Mars again. We want to teleport E to M. That is, send our electron from Earth to Mars. To do this, you need to add an additional electron entangled with M. Let's call it X. Then you should make E come into contact with X, and then the information content of E will be transferred to X. As a result, the electrons of E and X will become entangled, but X is also entangled with M. So information from E will also go to M. Thus, the electron of M will become an exact copy of E. In 2006, a team of researchers from Vienna applied this method to teleport cesium gas across the Danube to a distance of 600 meters. The gas consisted of over 1 trillion atoms and could be seen with the naked eye. A year later, scientists from the US National Institute of Standards and Technology managed to teleport photons through fiber optic networks. The particles have moved 100 kilometers this time. And in 2017, Chinese scientists teleported a photon into space for the first time to a height of more than 500 kilometers. To do this, the researchers had to make over 1 million attempts to successfully entangle a bit more than 900 particles. It was possible to overcome such a huge distance thanks to the quantum repeaters. Such transmission stations do not allow the momentum to fade and the photons to get lost. Based on the teleportation of particles, scientists are also developing quantum computers. You would certainly be pleased with such a gadget at home. It's impossible to hack due to the observer effect. Having tried to intercept the information, the hacker would instantly change the particles. You'll receive a hack alert and your data transfer will be instantly suspended. World leaders in high technology, such as IBM and Google, are already competing in the creation of such super devices. But so far, quantum computers have not yet surpassed the classical ones in their capabilities. In the future, when quantum computers improve, scientists want to use them in teleports. They'll help to scan the entire human body at the quantum level, and this is an unthinkable number of atoms and particles. Even the bacterium of E. coli contains 9 times 10 atoms to the power of 10. In the human body, there's at least 7 octillion atoms plus 27 more zeros. It's more than the number of stars in the observable universe. And every atom would have to be teleported. At the English University of Leicester, they calculated the power required for this. It turns out that teleporting all of our particles would require a colossal bandwidth and about 10 gigawatt hours of power. That is, moving a single person would require the use of all the UK's electricity over 1 million years. And it would take about 4.8 million years to transfer this data. The process would take about 350,000 times longer than the universe exists. It would be faster to just walk it through. In addition, with quantum teleportation, you'll need the most powerful protection against the slightest errors or failures. Can you imagine what the loss of at least one atom of your hand can turn into? You're unlikely to be satisfied with the result. Even greater troubles can be caused by interference in the data transmission process of a foreign body, approximately as in the science fiction film The Fly. There, a fly got into the teleport with the young scientist. The computer, assembling the body after teleportation, connected its cells with those of the insect. As a result, the scientist turned into a terrible mutant. You definitely won't be pleased with one more thing. Due to the influence of the observer, when the atoms are carefully scanned, the original object is destroyed. So there won't be 100% identical you after the transfer. But don't hurry to say goodbye to quantum teleportation. Science sometimes goes crazy. Recently, Mikio Kaku, a professor in the City College of New York, suggested doing it without the complicated quantum entanglement. He decided to create a teleport like an ultra-high-resolution MRI scanner. The accuracy of the device should reach 1 atom per pixel. To transmit data, the professor wants to use X-rays with ultra-short waves and high frequencies. They'll be able to carry 1 million times more information than optical fiber. Your data will be encrypted at the quantum level and sent into space, transmitted over a satellite network, and then sent to a quantum computer for unpacking. Kaku hopes to test his theory within 10 years by moving a simple molecule into orbit, and then doing it with DNA. Gradually, the time will come for teleporting humans. According to the professor's calculations, teleports will appear within 100 years. But what if you don't want to wait that long? Then check out a bonus from Mark Zuckerberg. The head of the social network Facebook, Mark Zuckerberg, promised the emergence of technology for teleportation as early as 2030. We're talking about the virtual and augmented reality. According to Zuckerberg, in 10 years, VR and AR gadgets will become fantastically advanced. With the help of VR-enabled smart glasses, everyone can instantly move to any place in the universe. That is, the picture will be so realistic that it'll create an effect of teleportation. You may agree that it's also a good option. You can travel through space and your body stays at home. The same, however, happens with quantum teleportation. If you decide to move to the moon, only complete information about your atoms will be transmitted, which means, in fact, that your clone would appear on the Earth satellite. But in any case, teleportation will expand the boundaries of the universe in an unprecedented way for each of us. There's still time to think whether it's worth sacrificing the uniqueness of the atoms of your body, which are constantly changing already. Which method of teleportation do you see as the most promising? And which would you like to use someday yourself? Write it in the comments. Don't forget to subscribe to the channel. We'll continue to amaze you with discoveries from the world of science and space.